Welcome to video series number 5, Volume Calibration with Hypertonic Saline. In order to streamline your cath lab workflow, most centers will apply this method of volume calibration offline after the case. In summary, two items will be needed for this method of volume calibration, the first being an average cardiac output value provided by some external reference. This is typically obtained from several averages of a thermodilution intervention or by the Fick estimation. Note we will use this average cardiac output value later on in the calibration process, however it is not needed during any live PV loop acquisition. The second item that is needed is a PV loop recording of a bolus injection of 5% hypertonic saline. In fact, we recommend that a minimum of 2 10 milliliter bolus injections of 5% hypertonic saline occurs per condition. A condition is defined as any single time a PV loop catheter is delivered into the ventricle. So for cases like a TAVR procedure, where the PV loop catheter and the TAVR valve are both delivered retrograde, we would have two conditions pre and post TAVR deployment, which would need to be calibrated separately. Please note that this event must be recorded by the Inca system, as this file will be applied to the volume calibration. Additionally, 5% hypertonic saline is the minimum concentration needed to warrant the desired effect for this volume calibration method. The more common 3% saline, used for flushing, will not be sufficient. This recording shows the expected PV loop changes when 5% hypertonic saline is injected. Note this artificial increase in volume, which is a key sign that the hypertonic saline bolus was successful. You want to see the loop shift to the right. This artificial change in volume is actually a change in conductance because hypertonic saline is more conductive than blood. As such, the Inca system is able to remove a phenomenon known as parallel conductance, which is an overestimation of volume being measured due to anatomical items contributing to changes in conductance, such as the ventricle wall, and not by the blood pool itself. Another way of stating this is that the hypertonic saline will essentially define the physical boundaries of the ventricle, as seen in red in this schematic, and provide an accurate measure of end diastolic volume, which will be used to calibrate the volume signal. Now we will actually walk through how to apply the volume calibration. In this particular example, we've recorded two baseline files, a third baseline file that we named a cardiac output of 4.02 liters per minute. This was determined by an average of 3 thermodilutions, and we have 2 hypertonic saline bolus injections. Note that by default, all recordings were saved as data files, and within dataset 1, which we will adjust for those files used in the volume calibration. Open any data file to go into the study. Next, we will select the volume calibration window. By default, we will be in dataset 0 and need to select dataset 1 to see our data files. Next, we will need to move the volume calibration files to their appropriate location. We'll start with the cardiac output file, which should be moved to an SVCal file. One easy way to remember this is cardiac output equals heart rate times stroke volume, thus all cardiac output files should be moved to an SVCal file. Next, we will move our 2 hypertonic saline files to their appropriate destination, which will be an EFCal file. From here, we will need to go into both SVCal and EFCal files to make some final adjustments before we apply the volume calibration. Let's start with our SVCal file. Because we're still within dataset 1, let's choose our SVCal files, where here you'll see that moved cardiac output file. The first thing we will do is uncheck the box and enter the cardiac output determined by the external reference in this window. The reason why we typically name this file cardiac output equals the value is so that one does not have to remember what this value is when inputting the reference number. Likewise, if I didn't have this pre-recorded, I can always make a copy of the baseline file and name it cardiac output equals whatever. After I've inputted this number, be sure to select the check mark such that these average values at the bottom populate. Next, we will take a look at our EFCal files, which are our hypertonic saline recordings. By double-clicking on a file, we will see the perceived increase in volume, which is used to determine an EF-cal number. These beats in red are automatically detected, which are the increase of volume determined by the hypertonic saline bolus injection. Notice we have two values, an R and an EF coefficient of regression number. We aim to have a number of at least 0.9 for each value, where R pertains to the end systolic point, or blue line, and the EF number pertains to the end diastolic number, or green line. Both are 0.99, which is perfection, so we will be able to average the two values here by clicking the check mark of both and updating the average value on the bottom. Before clicking apply to finalize the volume calibration, double check that the SV-cal and EF-cal calculated values have populated with some new number. Recall that these aren't direct measures of stroke volume or ejection fraction and are simply arbitrary numbers used for the volume calibration. I am ready to click apply. After this cycles through, we will double check a baseline file to confirm that our red PV loops have turned to yellow, indicating that the calibration is complete. Here you will see our fully calibrated data. Recall, a yellow signal means that it is fully calibrated and ready for analysis. Alright, you made it. In summary, the two items during the intervention that we need are number 1, to take note of the cardiac output value determined by some external reference. Number 2, we need to record any hypertonic saline bolus injections. Again, that's 5% hypertonic saline. After the intervention, we will move the file dedicated to the cardiac output reference to an SV-cal file and move the hypertonic saline files to an EF-cal file. Within the volume calibration window, we will then view the SV-cal file and input the cardiac output value determined by the external reference in the cardiac output reference column. Likewise, on the EF-cal side, we will look at the saline files and confirm that the EF and R values are greater than 0.9. If less than 0.9, we have the ability to move the end systolic and diastolic markers and or choose to include or exclude beats within the volume calibration range to improve these values. Finally, confirm that both the SV-cal and EF-cal values at the bottom of the volume calibration window have been updated before clicking apply. After clicking apply, your PV loops should turn to yellow for any data file within that dataset, indicating you're ready for analysis.